Now say next question. By computing the shortest distance, determine whether the following lines intersect each other. So first sub question, r bar equals to I minus j plus lambda into 2i plus k. This is equation of first line in vector form. And second equation is r bar equals to 2i minus j plus mu into I plus j minus k. So we have to use the concept of shortest distance between two lines. When shortest distance between two lines is 0, then that two lines intersect each other. We know that if r bar is equals to vector a1 plus lambda into vector b1 and r bar is equals to vector a2 plus mu into vector b2 are equation of two lines, then the shortest distance between these two lines we calculate by using the formula d is equals to in mod vector a2 minus vector a1 dot b1 bar cross b2 bar upon magnitude of b1 bar cross b2 bar. So using this formula we can find the shortest distance between these two lines. So first we compare the given equations with these two equations and find value of vector a2, value of vector a1, then value of vector b1, value of vector b2 and their cross product and difference first. So here vector a1 is, therefore vector a1 is equals to I minus j vector b1 equals to 2i plus k vector a2 equals to vector a2 is equals to 2i minus j and vector b2 is equals to I plus j minus k. Now first we find vector a2 minus vector a1. So right here vector a2 minus vector a1 is equal to, so vector a2 is 2i minus j plus 0k minus vector a1 is I minus j plus 0k. So we get a2 minus a1 as 2i minus I, that is simply I, minus j, this minus minus plus j, so we get 0. So 0j plus 0k. This is value of a2 bar minus a1 bar. Now we have to calculate the value of b1 bar cross b2 bar. So we write here b1 bar cross b2 bar is equals to, in first row we write ijk, then b1 bar, that is 2 0 1, because we write this as 2i plus 0j plus 1k, so we write 2 0 1. Then vector b2 1 1 minus 1 1 1 minus 1. So we calculate this determinant. So first I cap into 0 into minus 1 is 0, 0 minus 1 into 1 is 1. Then next minus j into 2 into minus 1 is minus 2 minus 1 into 1 is 1. Then plus k into 2 into 1 is 2 minus 1 into 0 is 0. So we get here 0 minus 1, that is minus 1 into I, that is minus I, minus 2 minus 1 minus 3 minus minus plus, so we get plus 3j, 2 minus 0 is 2, so we get here 2k. So in this way we get the value of b1 bar cross b2 bar. Now we have to find their magnitude. So we find its magnitude b1 bar cross b2 bar is equals to under root. So minus 1 square plus 3 square plus 2 square. So after calculating we get minus 1 square is plus 1, 3 square is 9, 2 square is 4. So we get here square root of 14, which is value of B1 bar cross B2 bar, its magnitude. So next we have to find this numerator. So first we find numerator. Therefore A2 bar minus A1 bar dot B1 bar cross B2 bar, which is equals to, so A2 bar minus A1 bar, which is simply I. So we write here I cap dot B1 bar cross B2 bar, we calculate here minus I plus 3j plus 2k. Now this is dot product. So I dot I is 1, I dot j is 0, I dot k is 0. So we get here I dot I is 1 and this minus sign means minus 1 into 1, or we directly write equals to minus 1. Equals to minus 1. This is value of numerator. We calculate the denominator. So using this formula for shortest distance between the lines, therefore required distance equals to, first we find the required distance. If that distance equals to 0, then that line intersect. If distance not equals to 0, that means that line do not intersect. So we find distance here. Now see sub question second. So the given equations are of the form x minus x1 upon L1, y minus y1 upon M1, z minus z1 upon L1, and the second equation is of the form x minus x2 upon L2, y minus y2 upon M2, z minus z1 upon L2. If the given equations are of this type, then distance between these two lines is given by b is equal to, in numerator, in determinant, x2 minus x1, y2 minus y1, z2 minus z1, in second row L1, M1, N1, in third row L2, M2, N2, and in denominator, in root, this M1 into N2, M1 into N2 minus M2 into N1, M2 into N1, its square, plus then L1 into N2, L1 into N2 minus this L2 into N1, L2 into N1, its square, plus then for this last column L1 M2 minus L2 M1, L2 M1, its square. So by using this formula we find the shortest distance between these two given lines. So first we compare the given equations and find the value of x1 y1 z1, x2 y2 z2, then L1 M1 N1 and L2 M2 N2. So we write here x1 is equals to 5, y1 is equals to 7, z1 is equals to minus 3, because plus 3 can be written as z minus minus 3. So we write here z1 equals to minus 3, x2 is equals to 8, y2 is equals to 7, and z2 is equals to 5, and then L1 is equals to 4, M1 is equals to minus 5, N1 is equals to minus 5. From this 4 minus 5 minus 5, then 7 1 3. So we write here L2 is equals to 7, M2 is equals to 1, N2 is equals to 3. Now we have to find this numerator first. So we calculate the determinant x2 minus x1, y2 minus y1, z2 minus z1, then L1, M1, N1, L2, M2, N2. This determinant equals to, now we require x2 minus x1, that means 8 minus 5, we get 3. Then y2 minus y1, we get 7 minus 7, which is 0. Then z2 minus z1, z2 is 5, z1 is minus 3. So minus minus get plus, so we get here 5 plus 3, that is 8. Then L1, M1, N1, so we write here 4 minus 5 minus 5. Then L2, M2, N2, so we write here 7 1 3. So calculate this determinant. So we get here 3 in bracket. Minus 5 into 3, minus 15 minus, so minus minus get plus, 5 into 1 is 5, then minus 0, so we not write the determinant. Now next, plus 8 in bracket, 4 into 1 is 4, minus, so minus minus get plus, 7 5 is 35. Now calculate this value, 3 into minus 15 plus 5, which is minus 10, plus 8 in bracket, so here we get 39. So calculate this value, minus 30 plus 8 into 39. So we calculate this value first, that means we calculate the determinant first. So we write this as minus 30. After multiplying this 8 into 39, we get 312. So after subtracting this, we get 282. So this is value of this numerator. Now we have to find this denominator, that means square root value. So square root we write here. Therefore square root of M1 N2 minus M2 N1, its bracket square, plus L1 N2 minus L2 L1, its bracket square, plus L1 M2 minus L2 M1, its bracket square, is equals to. Now this M1 N2 minus N1 M2. So this bracket value is the value of this M1 N2 minus M2 N1. So we write here. So from this minus 15 plus 5, which is minus 10. So we write minus 10 its square. Then L1 N2 minus L2 N1. This value we not calculate. So we calculate this value first. So 4 into 3 12. 4 into 3 12. 12 minus minus plus 35. Minus 12 plus 35. So 4 into 3 12 minus minus plus 5 into 3 35 its square, plus then this value we have calculated already, L1 M2 minus L2 M1, which is 4 plus 35, which is 39. So we write 39 its square. So first we add these two. So 35 plus 12. So we get here 47. So we directly write in next step here 47. Now you have to calculate the square of each term. So we write this as 10 square, which is equal to, we get 100. In square root we get 100. Square of this 47 we get 2209. Square of this 39 we get 1521. So after adding this we get 3830. Now we calculate the value of numerator, which is 282. value of this root, which is in root 3830. So we write the values of numerator and denominator. Therefore, the shortest distance is, so now see last question of this exercise, question number 8. If the lines x minus 1 upon 2 equals to y plus 1 upon 3 equals to z minus 1 upon 4 and x minus 3 upon 1 equals to y minus k upon 2 equals to z upon 1 intersect each other, then find the value of k. So we know that when two lines are x minus x1 upon m1, y minus y1 upon m1, z minus z1 upon n1 and x minus x2 upon l2, y minus y2 upon m2, z minus z1 upon n2 intersect each other, then this numerator is 0. Therefore, x2 minus x1, y2 minus y1, z2 minus z1, l1, m1, n1, l2, m2, n2, this determinant equals to 0. Because any number upon 0 we get 0, that means we get d equals to 0 when numerator is 0. So here these two lines are intersecting, that means this determinant equals to 0. So we have to compare given equations with these two equations, and first we find value of x1 y1 z1, x2 y2 z2, then l1 m1 n1 and l2 m2 n2. So we write here the values of l1 m1 n1, l2 m2 n2. So comparing, we write here in solution, here x1 is equals to 1, y1 is equals to minus 1, z1 is equals to 1, x2 is equals to 3, y2 is equals to k, and here this z can be written as z minus 0, so z2 is equals to 0. So you can write here z minus 0 upon 1 for your convenience. So we get x2 x1, y2 y1, z2 z1, and l1 is equals to 2, m1 is equals to 3, n1 is equals to 4. Then l2 is equals to 1, m2 is equals to 2, n2 is equals to 1. So we have to calculate this determinant value and we have to take that value equals to 0. So we directly substitute that value in this form. Therefore, in you.